By the end of this lesson, you will be able to understand the core principles and components of the transformer architecture, explain the attention mechanism and how it enhances sequence translation, demonstrate how attention provides transformers with their flexibility and power, implement a basic attention mechanism using Python. Transformers and attention mechanisms underpin many advanced AI systems. But what exactly is a transformer model? Transformers are powerful deep learning models that convert one sequence into another. Imagine them being used to translate a sentence from English to French. I am happy today. Je suis heureux aujourd'hui. Sometimes it works, but a lot of the time it doesn't. I have brown eyes. J'ai les yeux bruns. While it may seem like translation is about matching words, in reality, languages have unique structures and nuances. Let's look under the hood of a transformer model. Each transformer comprises an encoder and a decoder. The encoder processes the input sequence, and the decoder generates the output. Unlike traditional models like recurrent neural networks, RNNs, which process data in sequence, transformers, powered by attention mechanisms, can understand the context in any order. Attention mechanisms allow transformers to focus variably on different parts of an input. Imagine translating "the red fox chased the tired rabbit." Here, attention lets the model emphasize fox more than red, based on the target language's structure and meaning. How does attention achieve this? The decoder observes all encoder states, assigns scores to them, then amplifies or reduces their importance based on these scores. This dynamic adjustment is crucial for accurate sequence transformations. Due to their attention mechanisms, transformers work faster and with more adaptability. This efficient design enables them to undertake tasks like document summarization and content creation, and even non-language tasks with high proficiency. Now, let's look at some code. First, we import the necessary tools from the Transformers library. The pipeline is a high-level, easy-to-use API for doing end-to-end NLP tasks, such as translation, summarization, etc. TF Auto Model for seek-to-seek LM is a class that allows us to generate sequences with a sequence-to-sequence model, specifically the T5 model in this case. Auto Tokenizer helps us to prepare our input data. Next, we define an English text sentence, which is a complex yet sensible narrative. We want to compare how different models translate this sentence into French. We then define two different translator pipelines, one using a transformer-based model, the Helsinki NLP Opus MT-ENFR, and the other using a recurrent neural network. The translator for the transformer-based model is quite straightforward. It directly uses the model and the built-in tokenizer for that model. For the T5 model, we need to first load the model and tokenizer separately using TF Auto Model for seek-to-seek LM from pre-trained and Auto Tokenizer from pre-trained, and then pass them as parameters to the translation pipeline. After setting up our translators, we translate our English text into French using both pipelines. Finally, we print the original English text along with the translations made by both the transformer-based model and the RNN-based model. By comparing these translations, we can examine the differences in performance between the two types of models. It's important to note that both the transformer model and the RNN model are state-of-the-art, but they have different strengths and weaknesses. The transformer model, for example, can handle longer sequences and capture long-range dependencies in the text better due to its attention mechanism. In contrast, RNNs, like the T5 model used here, process sequences step by step, which can make them slower and less efficient at handling longer sequences. This code provides a way for you to explore these differences by manipulating the input string. Try a few different input strings in English to see if you can trick the RNN into handling it differently to how the transformer handles it.